Okay lads, hopefully we're all keeping well. I want to do the answers to the assignment on the volume of a prism. But before we get into the answers, I'll just give you a wee brief rundown of what a prism is and how to actually work out the volume of it. A prism is a 3D shape. Okay, I'm going to draw a few examples here, right? It's a 3D shape that is uniform all the way through. In other words, see this here, part of it here that I'm colouring in. There's an example of a prism. That's called the cross section, and it's the same all the way through. In other words, as you move through the prism, it's the same thickness, right? It's the same as this. This is called a cylinder, this one. And there's the cross section of the cylinder that I'm colouring in at the front. And that's a circle, and it's the same thickness all the way through. In other words, it's uniform in thickness, right? There's one there, which is a triangular prism. It's like a Toblerone box or a tent, right? Again, that's called the cross section at the front, and it's the same uniform thickness all the way through, okay? And you could have one with a trapezium on the front, like this. Okay, just colour that bit in. And again, that is a prism because it's the same all the way through. So the word prism means it's a 3D shape that has a uniform cross section throughout the entire shape. Now, an example of a 3D shape that wouldn't be a prism is a cone. This isn't a prism, because as you cut through a cone, the cross section gets smaller. And I've actually drawn them in there. You can see they actually get smaller. So it's not uniform. In other words, it tapers in, right? Another example would be like a snooker cue. If I was to draw just an example of one out, like that. It's thicker on one end than it is on the other. So it's not uniform. In other words, the cross section changes as you move along the shape. So those are not prisms, but all these ones that I've drawn up above are prisms. Now, to get the volume of a prism, it's a simple formula. It's volume equals the area of the cross section multiplied by the length of the prism. That's how you do it. So if you wanted to get the volume of this here, you would get the area of the front and you times by the length, whatever that is. Same here, you'd get the area of the front here and times by the length. Same with the tent there, or the triangular prism, area of the front times by the length. And the trapezium, area of the front times by the length. But the problem with working out volumes of prisms is you need to know how to get the area of different shapes, because different prisms have different cross sections. So in this one, you'd need to know how to get the area of a square, you'd need to know how to get the area of a circle, a triangle, a trapezium. So those are all important. So as I work through the booklet, I will be using my calculator because it's M3 or M4, depending on the module you're doing. And what I can do is I'll talk to you then and explain to you how I work out the volume of each one, and there'll be different cross sections on how I manage that. Okay, but that's an overview of what a prism is and how to actually the formula for working out the volume. So if we look at the assignment then, right, you're asked to work out the volume of this cuboid. Well, what you can see is the cross section, which I'm going to colour in the front of it, is a rectangle. And the length is 9, so the answer is 2 by 3 by 9, okay, which is 54. Now it's centimetres cubed, 54 centimetres cubed, right? Below is a cube. Remember, a cube has the same lengths on each side all the way around, so it's 5 by 5 by 5. Work out the area, the volume of it. So the answer is going to be 5 by 5 by 5, which works out as 125 centimetres cubed. Okay, so pretty easy start. moving on to the next question, okay, which I'll fold over here. Hold on, fold the page. The next question is a triangular prism here. So work out the volume. Let's work out the area of the front. If I draw the front out, it's 4 there and 5 there. Now the area of a triangle is base by height divided by 2. So that's going to be 4 5s or 20. Divided by 2 is 10, is the area of the front, multiplied by 12, which is going to be the volume. So the answer is 120 centimeters cubed. Okay, this one, below is a prism. The cross-sectional area is 21, so it gives you that at the front. The prism is 6 in length. Work out the volume. So to get it, you just go 21 by 6. Okay, and I'm getting 126 for that answer. So that's pretty easy. Next one. You've got this prism, work out the volume. Now, what you need to do first is work out the area of the front of it, which is called the cross section. Work out the area of that. And whenever you get that answer, you times by how deep the prism is, which is 10. Now see the area of this? It's an L, this cross section, so I'm going to sketch it out. And I'm going to draw a wee dashed line across to make it into 2 rectangles. So let's fill in a few distances, okay? We know that this is 3, see this distance here? And we know this is 8, so this must be 5. See from there to there? And this must be 3 from there to there. Filling in some distances. This is 9. And we know this is 5 and this is 9, so this must be 4 across the top here, because this is 5. So that's just filling in a few distances. So to get the area of the front of this, I'm going to say that this is rectangle A and this is rectangle B, and I'm going to work them out. So A has an area of 20, 4 by 5. And B has an area of 9 by 3, which is 27. So the total area of the front is 47. And I'm going to times that by 10 to get the volume, and I'm getting 470. So you need to be careful with that. You could have split it this way, by the way, by drawing a line down here. And it might have been a bit easier. You could have done it that way, because there's 15 for that. And then you know, you would have been able to work out that's 4 8s or 32. 32 plus 15 is 47. Okay, so you can do it that way, but the way I did it is absolutely fine. 470 is what we're looking. So that was question 5. Question 6. Below is a triangular prism. Find the volume. Well, look, there's the front of it, called the cross section. So let's find the area of that first, which is 3 by 7 divided by 2, which is 10.5. Okay, just check that. Yep. And then I'm going to times that by the length of the prism, which is 10. And I get 105 centimeters cubed. Okay, question 7 is looking at the volume of this cylinder or can. It's a can of beans, right? Now, a cylinder has a circular top, it's a prism, and has a length, and then a circular bottom. So it's uniform all the way through. So this one has a radius of 3.5 and a height of 11. So what we need to do is we need to work out the volume of this prism by first of all working out the area of the cross section, which is a circle, and then timesing our answer by 11. So it's going to be, remember, the area of a circle is equal to pi times r squared, right? That's going to be the formula we're going to use, and then we're going to times it by 11, our answer. So it's 3.14 by 3.5 squared by 11. That's what we're going to type into the calculator. So 3.14 times by 3.5 squared times by 11, and I'm getting 423.115. Now you could round that up if you want to 423.1, but that's the way that's working out. So that's number 7. Okay, question 8. Find the volume of this triangular prism. Again, you've got the triangle at the front. So you want to get the area of that, which is 8.5 by 6.8 divided by 2. Okay, which works out as 28.9. And then you want to times that answer by 21.5, which is the length of the prism. So I'm getting an answer of 621.35. Okay, fairly easy. Get the area of the triangle at the front times by 21.5. Question 9, what we have is a trapezium on the front. So it's called a trapezoid prism. And you can see here you have that area there. The cross section is a trapezium, and then you've got 12 here. So to get the area of a trapezium, there's a formula. So if I draw a trapezium out, on a trapezium you've got 2 parallel sides, which I'll mark with arrows. Those are parallel. One of them we'll call A in terms of its length, and the other B. The perpendicular height between them we're going to call H. So it's at a right angle between the 2 sides. So the area of a trapezium is a half A plus B times by the height. So if you add A and B and you half them and times by the height, that gives you the area, and then we're going to times that by 12. So here's the way I'm going to work it out. It's going to be a half times 6 plus 8 times that by 5, then times that by 12, and that should give me the volume. So I'm going to go 6 plus 8 times by a half times by 5 times by 12, and I'm getting 420 is the final answer for that. So you need to know this. You need, in order to get the volume of this prism, you need to know how to get the area of a trapezium, which is the formula. And by the way, the good news is that formula is given to you in the formula booklet, so you don't have to remember, but you need to know how to use it. Okay. Next one then is question 10. Okay. So it shows a prism in the diagram, right? The cross section is a parallelogram. Work out the volume. Now, a parallelogram is a 4-sided shape that has 2 sets of parallel sides. So see those are parallel and those are parallel. Now, to simply get the actual area of a parallelogram, it is the base length, multiplied by the perpendicular height between the parallel sides. See there? So the area is B times H. Okay, that's all you need to do. So if I'm looking at this diagram, I can see that it's going to be 9 times 4, which is 36, is going to be the area of the front, and then I'm going to times that by 14. So my answer is 36 multiplied by 14, and I'm getting 504 for that. 504. Question 11. The diagram shows a trapezoid prism. The area of the cross section is 55, so I'll write that in our diagram, 55. The volume of the prism is 330, so V equals 330. Work out the length of the prism. Well, I'm going to just draw that line in there, and I'm going to call that L. Now, I know that 55 times L is equal to 330. So all I need to do is divide 330 by 55, and my answer is 6. So that was just reversing the formula a wee bit by dividing by 55. Okay, next question is question 12. Okay, and that's the last question, I think. So you've got a cylinder. Calculate the volume of cylinder. Leave pi in your answer. Okay, remember what we have here is a circle on the bottom, and the formula for the area of that is pi r squared. And then to get our volume, we're going to times that by 9 then, which is going to be the height of this cylinder. So the volume is going to be pi times 4, which is the radius squared, times 9. Now 4 9s are 36, so the answer is 36 pi. Okay, so that's the answers to that assignment. Have a look over what you've done. Make sure if you've made any mistakes, you fix them, correct them, and you can resubmit work to me if you want with corrections. Okay, thanks, good luck.